Okay, let's get started. Thank you for being here. Classes on the Friday before a long weekend are often not very well attended, so thank you for being here. While we're on the subject of schedule here, where are we and where we're going? So today we are going to finish off Lecture 8. So we've been talking about the HCI design process and how that differs from the software engineering design process. And the HCI design process, we're putting user testing first. User testing seems like kind of a trivial thing to do. Give your system to your users, the alpha version, the beta version, get some feedback and improve it. Hopefully what you will take away from Lecture 8 today is that it is not always an obvious thing to do. We will then switch in Lecture 9 and 10 to talking about information spaces. So in HCI, you're often creating interfaces for new software and technology, and you're actually constructing a novel information space. So an information space, examples would be the net, Google Maps, and in your case, eventually, an educational ASL system that your student or your user is going to navigate through. They're never going to have seen this information space before. How intuitive is it going to be for them to move forward, quote unquote, through that information space? What does it mean to make progress in learning ASL using the Leap Motion device? How do you create an information space that makes, how do you create an interface that makes a new information space intuitive, visible, consistent, familiar, all the things that we've talked about before. So this is one of the great things about HCI. Often if you go and work in industry in HCI, you're creating a new information space, a new system that has new functionality that your users have not seen before. How do you project the structure of that information space to them? That's what we're going to talk about in lectures 9 and 10. Before we do, let's just go back to deliverable 6 for a moment. Has anyone gotten started on deliverable 6 yet? A couple people. Okay. I see everyone who just put up their hand, they put up their right hand. So we mentioned righties and lefties briefly last time. I want to talk a little bit more about this one because I realize that this is when righties and lefties get into a little bit of trouble in deliverable 6. Okay. Think about the following. You are a righty. Your system is working, you read in your 2 digits, you get 80 or 90% prediction accuracy, you grab someone else from the, this is this year's class, you grab somebody else from the list here and you read in their digit, which becomes your 3rd digit, and suddenly your KNN algorithm fails miserably, right? You can be pretty sure that if it worked for the other student and it's failing miserable for you, either 2 things have gone wrong. Either you have failed to incorporate their data correctly, or they're a lefty, right? Okay, I can't help you figure out which of the 2 it is. I've left off from this list who is a righty and who is a lefty on purpose. You need to figure that out. Okay, if you're a righty and you import lefty data, what do you need to do? Flip it. How do you flip it?
Math.
What's that?
Math.
Yes, you use math to flip it. Can we be a little bit more specific than that?
Just flip the axes.
Flip the axes.
Like a negative, I don't know, was it?
Which axes?
X-axis.
The x-axis, right? That's it. So grab all of the x coordinates out of that 30 length vector and just multiply them by -1, right? That will turn lefty data into righty data or vice versa. Okay, at this point you have a choice. You can read in all your data and flip just lefty data so it becomes righty data, and continuing with your system will only work for righties, right? Because when you finally deploy this to a user and you don't know whether that user is a righty or lefty, then it's going to work if they're a righty but not if a lefty, right? Okay, in terms of grading, we don't care. If you make a righty-only system or a lefty-only system, that's fine with us. You can also make an ambidextrous system, so something that's robust to righties and lefties. How? How can you render KNN robust to righties or lefties?
Import more than one data set for that sign.
Yeah, you could. So we could read in, right, for each of the 10 digits, you can try and find from this data set and from this, you can probably find 2 instances of each digit, one from a righty and one from a lefty. It might take you a while to figure that out.
You could just, when someone puts their hand over, see if it's a right or left hand by like the orientation of the fingers, and then automatically flip it.
You could actually look at the gesture data and infer whether it's a righty or a lefty, and if it's the latter, flip it. Absolutely. What else could you do?
Could you just ask them?
You could ask them, right? So again, this is HCI. You're free to choose the interface. You can just ask them. What else could you do?
Duplicate every data set and flip it.
Absolutely, right? So take all your data set, flip along the x-axis so you double the amount of training data, and just give that to your KNN. Now your KNN is robust and it doesn't care whether it's a righty or a lefty. So again, lots of different ways to solve this problem from an HCI point of view, right? We're thinking about our users. Do we want to explicitly ask them? Do we want to make a system that only serves the righty community or the lefty community or both? And tying our thinking about our users to technical decisions, right? Are we going to double our training data? Are we going to try and explicitly detect whether we have a righty or lefty? There you go. Okay, if you are a lefty, and you are importing mostly righty data, this is probably much more important to you, right? So if you're a lefty, you're probably going to want to go with this KNN trick or explicitly detecting the hand and flipping it. Okay. Trying to serve well our minority lefty community here. Okay, we're all good about righties and lefties? Any other questions about deliverable 6? Okay, so before we jump back to lecture then, I want to just go to the end and just remind everyone that this deliverable is deceptively short because you're actually repeating steps 19 through 27 10 times, which you can do. It takes a little bit of time to do it. It's a little bit tedious to do so. You can change the code that you develop through 19 through 27. That makes it easier to add in the 3rd, 4th, 5th, and so on digit. So that's not explained. If you know how to figure that out, that will allow you to iterate through steps 19 through 27 much faster. Again, we don't care. It's up to you. As long as you get pretty good prediction accuracy by the end when you've incorporated all 10 digits. All good? Okay. Let's see, one other housekeeping note that I wanted to mention before we get back to lecture. You remember Jeff, the CEO of Zemery Corporation. He was at the World Maker Fair in New York City last weekend. They had 1,000 people come and use Zemo. Most of those interactions went pretty well thanks to the user testing you all did the week before that, I think. So thanks for that. There's a lot of interest, and he's now looking for a CS student who will work on creating a debugger extension for Visual Studio Code. That's all Greek to me. If that means something to you, you might want to email Jeff and see what he's got on offer. This is an open source project. You will get paid and recognition for adding an open source component to Zemo. So let's see, where Jeff's email is jeff@zemery.com. If you're interested, just email him directly. Okay. Okay, so back to the schedule. Again, we're working our way through lecture 8 here, the HCI design process. Remember, no class on Monday. We'll pick things up on Wednesday when your deliverable 6 is due, and we'll talk about deliverable 7 next Wednesday. Okay, so again, we were talking about this design process that has this star pattern where we're developing, if you're part of a large HCI development team, you're developing a lot of aspects of the system in parallel. Some people are working on scenarios, some on prototyping, some on requirements, and those sub-teams are periodically going back to the users. They may be exposing the users to a prototype, to a set of requirements, a conceptual design, a scenario. So there's lots of different kinds of things that you might use your users to evaluate. We ended last time by talking about prototyping, and the key to prototyping is trying to create cheap prototypes, right? You don't want to write 10,000 lines of code for your interface and realize there was a fundamental flaw in your assumptions, right? It just doesn't work at all for lefties no matter what you do. You have to trash your 10,000 lines of code and start from scratch. You might, through basically just drawing some pen and paper prototypes and putting those in front of your users, actually catch some of these non-obvious differences in your users that are going to make a difference for the system. So we looked at a bunch of them last time, very cheap storyboards, pen and paper prototypes where each piece of paper is a pane of your interface. We talked about then moving on to Wizard of Oz prototypes where you might actually start to have a bit of a functioning front end, but there's no back end yet, so the Wizard of Oz or one of the developers is actually supplying the new piece of the interface whenever the user clicks on a button or slider bar or a widget. Once you do that, now you might actually remove the Wizard of Oz and start to add scripts that run code when the user clicks on buttons. So you're sort of cobbling together different executables into your system, keeping things very modular. So if one of the scripts or one of the interface, one of the aspects of the system doesn't work, you can replace it relatively easy. And you're trying to save system integration till the last step, right? Creating one single executable that supplies the full system. It takes a lot of debugging and a lot of time. You want to make sure that you've worked out all the kinks in the interface and you're pretty clear about who's going to use your system, where and when, before you sit down and attempt full system integration. Okay, that's where we got to last time. So we were talking about prototyping. I don't think we need to really talk about 3D printers. This one's kind of obvious these days. Depending who you go work for, part of the HCI enterprise might involve novel hardware, right? Google Glasses. What should the physical glasses actually look like, right? There might actually be a hardware component to what you're doing, and if there's any hardware, there's also ergonomics, right? Does it actually fit with the way the person wants to use the system? Right? Even with the Leap Motion device, which is kind of obvious, it sort of matters where you put it on the table, how it's presented, so that the user uses it in the right way. Okay, so 3D printing is making it easier, like the pen and paper prototypes. The hardware side of this is it makes it relatively cheap to create physical prototypes of a system before you actually build the final hardware. Okay, I think you all kind of know how this works, right? 3D printers were an inspiration born out of 2D printers that eject ink onto a two-dimensional surface. And the idea in a 3D printer, or most 3D printers, is basically do the same thing. So emit or deposit material in a two-dimensional plane that creates a growing three-dimensional object. The original 3D printers used thermoplastic, which had a relatively high melting point, so they would actually be ejecting liquid plastic. When it came into contact with the base, or the growing object would rapidly cool and solidify by the time the right head came around to deposit the next layer of the object. Right? That was about 10, 12 years ago. Since then, there's all different kinds of 3D printers now. The million-dollar question in 3D printers is printing multiple materials. So this conference that I was at on Monday about soft robotics, there were a lot of people talking about 3D printers that could eject or could write plastic, ceramics, metals all together. So you could create not just a plastic replica of something, but a fully functioning machine. For roboticists, the dream is to design a robot in simulation and then 3D print a fully functioning robot that could walk out of the 3D printer. We're actually getting pretty close to being able to do that. We're not quite there yet, but that's where we're going. Okay, just an aside about physical prototyping. Okay, the main message in lecture 7 and 8 is not so much about scenarios and prototyping, but user evaluation, right? Everything we've said about HCI, we're trying to put people first. That's particularly important during the design process. So what does it mean to do user testing well? This is important because when you develop your final system and you present it at the end of this course, a big part of your grade is going to come from how you did user testing, right? You could take your ASL educational system, give it to your flatmate, and say, use it and tell me how it works. They said, it was okay. I learned 3 out of 10 digits. Great. What are you going to do with that feedback to improve your system? Right? So what does it mean to conduct user testing in a good manner, which elicits very specific measurements from the user testing, and that those measurements are then able to inform what aspect of your interface you go back and improve? Okay, so reviewing, again, it might not be the system, it might be evaluating prototypes or requirements, but central here is measurement. What are you measuring when the user interacts with your prototype, or they read the requirements and you ask them to find things that are vague or incorrect in the requirements, or they're interacting with the Wizard of Oz interface? What are you, prototype, what are you measuring during that interaction? Okay. If you go work in industry on large projects, often the nitty-gritty details start to take precedent over user needs. So people start to focus on what the system can do and what's written in the specs, and the users are kind of forgotten along the process. So we want to try and make sure we don't back ourselves into a corner where users are saying, this is great and all, but I will not use this when this becomes a full system. Okay. Evaluate early, often, and everything. So we're trying to find ways to test requirements, conceptual design, scenarios, and so on. Most of user testing is done internally, right? If you become an HCI designer, the ones that do really well have a good mental model of their users. So you may not be a lefty yourself, but as you're finishing your ASL educational system, you should be thinking about what would it be like for a lefty who knows nothing about Leap Motion or ASL to use this system, right? Can you sort of mentally simulate user testing as you're developing your system? Okay, so that's informal evaluation, but of course you also want to do as much formal evaluation as your budget allows. Okay, so how does this evaluation process unfold? Well, the first thing you've got to figure out is, why are you doing user testing? Specifically, again, in industry, you're going to have a certain time budget, a certain user budget, and a certain financial budget to do user testing. You better allocate those budgets efficiently. What are you hoping to get out of this evaluation session, right? So for Jeff, his goal with you all was to test the tutorial. I don't think he did much with the full game, right? The focus was mostly on the tutorial, right? He wanted to work out the kinks on the tutorial because that was really what they were using at the World Maker Faire, right? There was a specific goal Jeff had in mind in conductor user testing with you all. Carrying out expert review. So there are HCI designers out there, professionals whose whole job is just focusing on the evaluation process. So advising you on how to go about conducting user testing, what measurements should be made, and how should those measurements be used to feedback and improve certain aspects of your system. Okay. Plan user testing using the results from your experts to sharpen the method of testing, right? We want to try and make this as specific as possible. What exactly is going to be measured? Make sure you have a wide user base, right? So if you randomly select a user population for your ASL system, if you pick 10 people at random that you know on campus, you're pretty unlikely to net a lefty in that sample. Right? A sample of 100, yes, you're probably going to get some lefties, right? So think very carefully about who you're going to recruit for your user testing. Okay, combine the results from all the user testing and compute some statistics, which we'll talk about in a moment. So we're not just focused on the mean, there are other statistics that will tell us something about what's working well and what's not working well in our system. Okay, and then report those metrics back to the designer in a way that they can isolate from the results what aspect of the system needs to be improved. Okay, so let's sort of walk through a cartoon example of how this might work. At the top level, you're usually trying to exercise these non-functional requirements, right? So just to refresh our memory, functional requirements usually have to do with kind of the back end of the system, the specific functionality that the system is supplying. In the HCI design process, we're focusing on these global non-functional requirements. They're not specific to any specific function of the system. They're sort of the global properties of the system. So is it visible? Are all the functions that the system provides, can they be found by a new user? Or how long does it take a new user to find all the functions that are available? How visible is functionality in the system? How consistent is it? Is it visually consistent? Is it conceptually consistent? And again, these are sort of vague things. What do we mean by that? Is it familiar? Does it project the appropriate affordances? What is an affordance?
Something reacts the way that you expected it to, or something acts the way you expected it to.
So that's probably more familiar, right? You recognize something, but what is an affordance? It's something that's projected by something before you interact with it.
It's something about the object that communicates how it's supposed to be used.
It communicates about how it's supposed to be used, right? So one way of measuring affordances is, does somebody interact with it well the first time, right? So someone might see a novel widget or something that they've never seen before in your interface. They go to interact with it. Did they interpret the affordance that it's projecting in the correct manner? And what would you measure during a user interaction to know whether you got your affordances right or not, right? So here are 12 of these non-functional requirements. I want you to turn to your neighbor and take about 2 minutes, and you can pick one or more of any of these 12 and think about doing some user testing. And what would you actually measure? What numbers would you pull out of that user interaction, where those numbers would tell the designers whether they got whether they got that particular non-functional requirement right or not in the system? Okay, before we do that, let's do visibility. Let's just go do one to get started. What would you measure to know whether all the functions are visible or not from the point of view of your users?
Time it takes them to respond to an action and actually find the function.
Okay, how long it takes them, right? So time is probably going to be something. What else is important here? So how long does it take them to find function f? So let's say your system offers 8 different functions.
The ratio of how many functions they use there are.
Absolutely, right? So imagine you do testing with 100 users and all 100 do different things with your system, but when you look across all 100 users, on average, they touched 7 of the functions and none of them ever touched the 8th function, right? So statistically, you might look at usage of those 8 functions, and if one is never used, either it's exceedingly rare and the things that you had the users do during the testing session, they didn't need function 8, they knew it was there, or it wasn't visible somehow. They never realized that function 8 was available, right? So this is sort of what you want to be doing, is thinking about what aspects should we measure in a limited period of time to pull out what's working and what's not working here. Okay, turn to your neighbor and see if you can come up with some of these very specific metrics to capture these non-functional requirements.
A lot of them are going like time-based, so like navigation almost the user, being able to move through various things using like a how many times did I do that? Familiarity, but he's constantly don't find there's only one way to do it. And find another way to get it done. Style. Maybe if they use flexibility, they make different tasks.
Maybe like for feedback, like how long it takes for them to figure out the issue that they're having. You know?
So if they make a mistake, how long can they get back on track?
Yeah, I think so.
Fully covered.
Asking.
Control is how easily they
I'll insert the first, not so first.
It's on you one for it's like 28 inches or something. And I'm like, there's time to switch back to this.
What does conviviality mean? Is the software polite? Does it defer to you? The example is always the the Microsoft Word paperclip.
My software is always free.
it's very yeah, what's the battery low? It's like 10%. You might want to plug in your computer. 7%. Plug in your computer now.
As soon as I add this my last 5 minutes,
So are we talking about
He had to write it.
I was just speaking oh yeah, familiarity.
That was me on assignment 3, was to print out the answers and data can Yeah. So I just kept redoing it until I got to redo this. I was trying to get on it.
Oh, really?
So
that system was not
yeah, well,
the
system
style of
kind of the broader system. Yeah.
not flexible.
Terrible.
Yeah, it was very
Okay, there was a couple questions about conviviality. What does it mean for an app to be convivial? This one's a little bit tongue-in-cheek, right? The quality of being friendly and lively. Yes, that is the literal definition. But what is the meaning in our HCI discussion here? Can you give me an example of a piece of code or an app that is decidedly not convivial, or vice versa? PeopleSoft, exactly. There's a great example, right? So convivial really is sort of tongue-in-cheek for, is the system aware of you, right? There was the very convivial Microsoft Word paperclip, right? Very friendly, very polite, right? A complete disaster, not because it wasn't convivial, but it was completely unaware, right? It was autistic. It had no idea what you wanted it to do. So modern examples, right, are notifications. Hey, just a friendly reminder that you might want to turn on function F and you say no or not now or a little bit later. A minute later, it comes back and says, hey, you might want to turn on, right? That is not convivial. It's not aware that, it's not paying attention to what you're trying to communicate to the system. Okay, so while we're on the subject of that one, what measurements would you take during user testing to make sure that your system is not falling into this convivial, non-convivial trap? There's actually a very common way of doing this that's used in practice.
It's abstract, but just how frustrated the user gets trying to use it.
Okay, we're getting on the right track, right? So putting people first, we're thinking about our users. You know yourself that if something is not being convivial, you get very frustrated. What do we need to measure?
The time it takes them to either decide they don't want to do it anymore or whether they continue doing it after.
Maybe. So I keep turning off the notification minute after minute every time I'm asked. Maybe. going to be hard to actually quantify frustration in this case. This is a big part of HCI design, quantify frustration. PeopleSoft completely doesn't care about your frustration, right? There's nothing going on there to measure it. Most software systems there isn't. What would you measure?
Why if you're making them like real angry, you can measure their heart rate.
Absolutely, we're getting there, right? So you can almost get that out of the leap motion data. Almost, not quite. Okay, yes, heart rate. So assuming we're not going to actually instrument our users, which sometimes you do in HCI testing, how would you quantify frustration? So when you're frustrated, your heart rate goes up. What else do you do?
Number of times you start clicking on things.
Absolutely, right? Speed between clicks, that's a pretty good measure, right? If you can get the force with which you click, that might be even better. So I'm recording the lecture right now.
I was gonna say how many times you swear.
There, that's the one I was looking for, right? So in a lot of HCI testing, they will tell you the microphone's on, we're recording the audio, we're going to put that through a speech processor, we will use whatever the state-of-the-art speech processor is, which has 90% prediction accuracy of the actual words, and then we're going to look for certain words in that audio stream. Absolutely, right? I'm guilty of this. I'm sure most of you are guilty of the same thing, right? It sounds silly, but again, this is what HCI design is about, right? Trying to quantify these things. If you, unbeknownst to you, half the users are frustrated because you didn't measure the right thing and you go to deploy your system, you're in trouble. Okay, what about some of the others here? How do we quantify how familiar or how well presented the affordances are? How well do you present, how well does the user know when they're in control, number 6, or when the system is in control? What would you record or what would you measure to get at some of these things? What were some of the ideas you guys came up with? Doesn't have to be number 6. Anything.
Like flexibility, we measured if the user can do certain things in different ways. How many different approaches did the user use?
Absolutely, right? So maybe in user testing, we say, look, you're starting at point A, and we'd like you to perform a function that will get you to point B, right? Go. How many different ways does an individual user find to do it? Across your users, how many different ways do they find to get from point A to point B? How long do those different paths take, right? That definitely will get at flexibility. Yeah, great example. Other examples? Yep.
With recovery, you were saying how easy, maybe gauge the time on how quickly they were able to get back to the original place they started.
Exactly, right? So they realize they've made a mistake or they've gone into a part of the system they don't, and they try and back up or recover to a certain place. How long does it take, right? Exactly. So you'll notice that in this discussion, we're talking a lot about going forward, different paths to, and so on. We're talking about navigation now, right? Navigation through potentially a new information space, right? When someone starts to navigate through your ASL educational system, what does it mean to go forward and back, or to go left or go right, or move horizontally or down or up? We'll get to that in lecture 10. What does it mean to navigate an information system? Let's go back to control here for a system, right? When am I able to do something, and when should I sit back and let the computer do something, right? You want to make sure that that's communicated pretty well in your system. How do you know when it's not being communicated well? What would you measure to know that control is not working well, or visibility of control is not working well in your current version?
Talking about like loading bars, like just expressing that something is going on.
Exactly. Wait for a second, right? Or the revolving rainbow or whatever, right? You may use those, but if you don't, if you're using something else, how would you know if the user's failing to understand that they should be waiting for the system to do something?
I guess if they continue to click on something.
If they assume that they're still in control and they're still trying to do things when the system is trying to do something for them, then you know, right? I wanted to focus on this one for a moment because this is going to be important, again, for your ASL system, right? So in your system, at some point, the program is going to put something up and ask the user to do something, and maybe you need a little bit of time to make a prediction or figure out is the user doing the right thing or the wrong thing. You might need to ask the user to just wait 1 or 2 seconds until they're shown a new digit, or did they get this digit right or wrong? How do you project that? How do you communicate that to your users? And did they interpret that messaging correctly? Right? You could put up the spinning wheel. Hopefully that will work. But maybe there's some other things you could do. Okay, last one. Let's talk about affordances. So you have a pretty new system. There's a lot of new functionality there that the user hasn't seen before. Instead of putting up paragraphs of text to say this widget or this part of the interface allows you to do this, you want to try and put up something visually that hopefully they can interpret relatively quickly without having to read a paragraph of text and interact with it correctly the first time. What would you measure there?
Just how they respond to whatever information you provide.
Right.
I know for a lot of us it was really easy because we saw you hold your hand like this over the thing.
You'd seen me do it, right?
So I mean, maybe just a simple visualization of a hand going through the motions really quick.
Exactly.
Seems
right.
like it would be intuitive then to just hold your hand over it.
That's it, right? So the affordance might be a quick video clip or whatever of you actually doing what you want the user to do. The affordance should be pretty clear, right? Without writing any text on it means when this video finishes, now you do it, right? So testing is pretty easy. Do they do immediately what was in the video when the video ends, right? You could measure that quantitatively. Okay. So I just wrote my own here, but it might be worthwhile, just a short homework exercise to go through and try and do this yourself. So here's another example I came up with of an affordance. So let's say that you see this on your screen. Let's see how good my affordance is. What would you do? Put your thumb on it and swipe down, hopefully, right? So I asked the same question of the class last year, and they said put your finger on it, but hopefully you noticed that actually this is a thumbprint, not a finger, right? So trying, again, something that we all have touch screens, but if you specifically want a thumb rotating counterclockwise, that might be an affordance, and it's an easy one to test, right? The minute that's flashed up on the screen, how many milliseconds elapse before a thumb is placed on the screen and swiped counterclockwise? How often did someone put a finger rather than a thumb? Did they interpret the specific affordance here? We want a thumb, not just a finger, right? Again, the black art in HCI testing is taking these sort of vague things like affordances and making them very specific and quantifiable through measurements you can make on a relatively standard laptop. Okay, so let's talk about the statistics then, right? Hopefully you're doing this testing. Once you've come up with your specific metrics, you're testing with multiple users, and you get back distributions, right? So for these metrics, you might get consistently good metrics across your users. So whatever the recovery functionality is in your system, most or all of your users recovered very quickly, or fast enough as it was specified in the requirement. So the requirements say, for every possible function in this system, all users should be able to recover in 5 seconds or less. And you do your user testing, and among all the users you worked with, they all recovered in less than 5 seconds. Check, right? That one's working. This obviously makes sense. If we have consistent low-scoring metrics, then our system is particularly failing in terms of feedback. What if you see large variance? What does that tell you? Remember that we're trying to collect these statistics to know where to go back and fix things. So in my little cartoon example here, we don't have to work on recovery. We definitely need to work on feedback. What about constraints here? What does large variance tell you? If you were an HCI designer and you just finished user testing and you got back large variance in one of your metrics, what would you do?
Retest.
Sorry?
Retest.
You could retest. Okay, let's say you retest and you get high variance again. So instead of with 3 people, you do it with 30 and you still see high variance.
Put out a survey,
Okay, what would be on the survey?
questions about how,
You want to try and get at why some people did poorly and some did better on
yeah,
this.
I wanted to see where their head was at, I guess.
Exactly. So you're on the right track, right? Again, we need to sort of work backwards now. And a lot of HCI design, again, is this going forward and backwards. So what do we need here?
Would you just kind of examine the people that were participating?
We could. So again, assuming you have the right budget, most user testing is everything is recorded, right? Video and audio and so on. You might go back and actually look at some of the raw video to try and figure out what's going on here. But before you even look at the video, given all we've said about HCI in this class so far, what's your intuition about the source of the variance?
Maybe it's just your software itself is not very clear.
Right, it has whatever, in this case, they're not very clear constraints, right? Some people are, let's say, violating the constraints and some people are adhering to the constraints.
Maybe it's just not very defined set of constraints and rules to really know what's going on.
It clearly isn't, right? Because some people are getting it and some aren't. So we're getting there, but what is it? Why? What is it about this that's causing this high variance? What's causing some people to get it and some not to get it? It could be random.
It's like previous experience with a similar system, or just in general knowing how these kinds of things work.
Okay, which would explain which of your group here, the ones that are high performing or low performing.
People who are high performing because they know what to do.
Okay, so that's a hypothesis, right? So let's try and hypothesize about why we're getting high spread. Maybe it's because some users recognize something from a previous system and their expectations about that functionality is supported in the new system. Others aren't familiar with this functionality they're seeing in the system and they're getting low performing statistics. That's one hypothesis.
Maybe our training data.
Okay, getting
if,
closer. Yeah.
If we don't have, say we have one left-handed person in the whole class, and I test, half left-handed, half right-handed, some it's going to work really well, and some won't work at all.
Exactly, right? So maybe it's because we have power users and novice users, or because we have righties or lefties, or because we have adults and kids. The variance is usually coming from the variance in your user population, which is why you tried to get a wide user base in the first place, right? So your system, at least for these specific non-functional requirements, is working for some of your users and not the others. But what is the partition that breaks your group in this high spread into high performers and low performers? Is it their experience with computers? Is it something physiological? Is it something anatomical? Is it something cognitive? Is it cultural? Is it because of English and non-English speakers? Who knows, right? You could maybe now go back in the video and actually try and figure out what the difference is. You could give a survey and say, you seem to have a really hard time with this part of the user interaction. Could you tell us a little bit more about that? Take that data. You may now have uncovered a new dimension of variation among your user population that you didn't catch in scenarios and prototyping. So you now go back and rewrite the requirements. And in the requirements, it says we're now going to flip all gesture data along the x-axis to make sure that our system is robust for lefties and righties, right? A lot of the dimensionality of variance among your user population you don't catch a priori, right? I was sort of pushing you at the beginning of this class towards some of these realizations, but if I hadn't, you definitely, hopefully most of you would start to realize that righties and lefties matter now in Deliverable 6. Imagine that I'd never said anything about righties and lefties, right? It might have occurred now or maybe later when you started to do some user testing and you observe someone do this rather than this, right? And you're in the last week of the class and you'd never thought about that dimension of change before, right? This is a big part of what HCI user testing is about. Get a diverse population and learn through actual interactions what aspects, what differences among your user base matters and what aspects don't. Okay. Okay, that's lecture 8. So now we're going to switch. Go back to the schedule for a moment. We finished sort of our discussion about the design process. During the design process, you're creating a lot of things, right? You're creating an interface, the front end. Your software engineers are building the back end. You're doing user testing. You're creating prototypes. You're creating all these other things. The thing that you're really creating is an information space. When you create your ASL educational system, your users are going to be navigating through a new information space, right? So what is an information space and how do we help users navigate through it? So we've only got a few minutes left. I'm going to go very quickly through this. We're all familiar with some of the traditional information spaces or user interfaces you find. These basically have slightly different structure, right? So if you think about the interface, like the command line, the terminal for Macs, or the DOS prompt for Windows people. We're thinking about sequence, right? Typing in one command after another. In the 70s and 80s, GUIs came along, which had a very different interface, which immediately created a different information space, right? Different windows onto that space. One of the best acronyms in HCI, the WIMP interface, Windows icons, menus, and pointers. So suddenly we had a new information space, and in this information space there were these novel conceptual objects, these things called windows and menus and widgets and icons and so on, which were new at that point, right? In both the command line case and the graphical user interface case, the exchange medium is the computer itself. We're now moving into more and more tangible interfaces where you're manipulating something that's physical, right? So a trivial example of this is a touch screen or something that you physically manipulate, right? Google Glass or Leap Motion, something you pick up and physically manipulate. We hear more and more about the Internet of Things, right? Think about interaction when someone is actually physically manipulating an object, right? That changes the information space. Okay. So we've got 3 minutes left, which is great because I have a 3-minute video to show you. This is the React table, which is a tangible interface. You're going to see the users manipulating a bunch of blocks, and there's going to be no text in this interface. Everything is visual and auditory. I want you to note all the metaphors you see in this 3-minute video, or however many we can watch in the next 2 minutes. Okay, this wasn't quite the video I wanted to show. There's a better tutorial one. This is a little bit of showmanship here, but that's okay. 1 more minute to go. What were some of the metaphors you saw in this interaction? Lots of physical interaction here.
turning one of the blocks to turn volume up or their effect.
So
just
tur-
like a knob like you would use on a stereo.
just like X, right? Just like a knob. There's the metaphor, right? It makes sense that if, without writing text saying, do this to turn up the volume, it makes sense that if you put this block and turn it, that the volume will change. Which direction will turn volume up and which direction will turn volume down? Without having seen that, right is louder. Okay, we will continue with the React table on Wednesday. You have a quiz due tonight, and deliverable 6 is due Wednesday night. Have a good long weekend.